power rule. Okay, so in our power rule itself, what we learned was that if y equals to, let's say, x to the power of 3, okay, our derivative dy over dx will be 3x squared. And then if y equals to 6x to the power of 5, okay, maybe not 5, maybe let's choose half. Okay, dy over dx will be 6 times half, x half minus 1. Okay, and then your derivative look like this. So essentially, break down the power minus 1. That will actually get you your derivative. Okay, so that's a quick recap about what we have covered. So notice that it relies very heavily so far in our entire A-Maths. Okay, the reliance on your indices is very heavy. So therefore, you really need to go and work on that area if you struggle with all these indices things. Okay. Today I want to look at some application questions, some extension of your derivative. So, one very important application of the derivative is that the first derivative is commonly related to gradient of tangent at a point on the curve. Okay? So it's an application. It doesn't mean that all derivative represents a gradient. It really depends on the context itself. Okay? Are we ready to start? 40 minutes just gone by like that already. Okay, the talking is non-stop. Me not saying anything doesn't mean I'm okay with it. If you're fine with this topic, then okay, I don't teach. Okay? If you're fine with everything, fine, I don't teach. Or you think you can watch video, I just give you the entire playlist that I did 2 years ago. You go and watch yourself. Okay, I know the time is late, you're a bit restless, but the noise level is unbearable. Okay, can I really start on this question now? Alright, so this question gave you a diagram, okay, representing the graph of y equals to 3x squared plus 2 over x. Okay, and then a point A to 13 is actually found on this curve. Okay, question wants you to find the gradient of the curve. Gradient of the curve at a certain point at A to 13. Okay, and then in part 2, at the point where the curve meets the line y equals to x. Okay, so let's deal with part I first. Okay, so I said that the first derivative is a way of us, way to help us, okay, find the gradient. So we know the equation of the curve. What we need to do is to find the first derivative of this, but with 2 over x. Okay, we know that it will be helpful if I can re-express it as a non-fraction Okay, bringing the variable up to the numerator. So this is x to the power of 1 in the denominator, bring up become x to the power of negative 1. Then we find dy over dx. Okay, so to differentiate, we bring down the power 3 times 2, power minus 1. Then the next one, 2 times negative 1, negative 1 minus 1. Okay, and we get 6x minus 2x to the power of negative 2. Okay. So this expression over here, okay, is a generic form of all the gradients of all the tangent. You can think about it like it's a formula. Okay, general formula of all gradient of tangents. Of the curve that we're talking about. Okay? So which explains why knowing differentiation is very helpful, okay, for you when it comes to Emaths. Because Emaths very often you need to go and find the gradient of the tangent of a certain curve. And you want to know whether your tangent is accurate or not. Okay? We are fully capable at this point now, okay, to actually differentiate the equation of the curve we're given. Okay, so upon differentiation, I know the general form already, but I want the gradient value at a particular point. We now know that the point that we're looking at is A213. So what we need to do with that information, okay, is that at A213, substitute the value of x into your first derivative. Okay, and then I can know the exact gradient value, okay, and that will be equals to 11.5. Alright, so this is how, in fact, for us teachers, okay, when I want to check the accuracy of your tangents being drawn, how good is the gradient value you give, we actually always differentiate it. Okay, we differentiate and then we get the value, and then we plus minus from there. Okay, but of course I'm not going to tell you the mechanics of us when you set our paper lah, but we plus minus. So whenever you need to draw a tangent, you need a plus minus 1 or 2, okay, integer values from the 11.5. Okay, that's just the general rule of thumb lah. But of course, different question we do different things also. Okay, so this will really help you in terms of getting that mark when it comes to your graph drawing. Okay, any questions? Then next in part 2, right? Okay, it says the point where the curve meets the line y equals to negative x. Okay, so we have the curve, we want it to meet the line y equals to negative x. So we need to go and find that point first. So do simultaneous equation solving. The denominator here by multiplying throughout by x. So we are solving 3x cubed plus x squared plus 2 equals to 0. Okay. Now we have 3x cubed plus x squared plus 2 equals to 0. I want to find the intersection point. How now? What should I do to solve this question? Any ideas? Is this familiar to you? Solve cubic, it's on power 3, huh? Okay, so yes, we use our calculator, but we must show the appropriate working. Okay, so using your calculator, type the cubic. Okay, then we find that we we can have x equals to -1. So we pretend we do trial and error, right? That's what we did in cubic. Let x equals to -1. Then we find that yes, it is equals to 0. Okay, so x plus 1 is a factor of 3x cubed plus x squared plus 2. Remember this? We learned it last year in your polynomials chapter 3, I think. Okay? Factor theorem. Right? Okay? Then, how? You find the factor already, what do we need to do next? Hello? What should we do next? After applying our factor theorem to find one factor, Ashley, x equals to x plus 1 equals to what? Or sequence of series of steps one, right? We are trying to solve this one. We do factor theorem to find one of the factor. I must still know the other factor, right? How do I know the other factor? Long division. Okay. So do your long division of your x plus 1. Minus 3, negative 4. Something wrong. 3x squared minus away x. Okay, long division, then I continue writing here, okay, the blue one. Erase this one. Intersection point of the line and the curve only. Okay? So this one, b square minus 4ac, yeah? Okay? So I know that the x coordinate will be -1. So at x equals to -1, the y coordinate of the intersection point must be 1. So the point is at negative 1, 1. Earlier on, I already know dy over dx is actually 6x minus away 2x negative 2. So gradient equals to 6 negative 1 minus 2 negative 1 negative 2. That's equals to negative 8. Sorry that it's a little bit messy. Okay. Give you a moment to digest this. Yes, Hannah? Oh, yes. Sorry, I wrote a mistake. Yeah, too many 3's. 3x cubed. Sorry, this one is 3x plus x squared plus 2. Thank you for pointing it out. Okay. Right? So the question requires us to find out, okay, what is the intersection point. If without the intersection point, I wouldn't know what is the x value to substitute into my derivative. Okay, so it's really a lot of work over here in order to find this, to substitute to find the gradient. Okay, to find the gradient itself is not that a difficult task. It is about finding the point itself that became a difficult task. Okay. So through this question, I want us to really know that, okay, don't try to think of each chapter of your A Maths as independent chapters. Okay, they can actually come in together, like over here, okay, your cubic stuff, into solving the question. Okay? Can? Okay, so tomorrow we'll have our EMATS WA. Okay, then after that Wednesday I will do a few more examples, okay, relating to gradient. Then we go into chain rule. Alright. So homework, okay, for your chapters 8. Okay, I'll try my best to return it to you by Wednesday. Okay, so that we can actually clear things out by this week. Okay. Then for chapter 12, even if I give you homework, I wouldn't have time to mark and return to you in time. Okay. Let's see. I'll do more of the classwork. Okay. Then maybe I'll give you a very short quiz. Okay. Just like maybe less than 10 marks that kind, just to test your skills of differentiating. Then at least that 1 or 2 questions I can know, okay, then I can give you the necessary feedback. Okay, so I'll give you a quiz on Thursday regarding this as well as on chain rule. Okay? But don't have to worry about the quiz, it's not like it doesn't carry any marks, okay, any weightage.